And finally, for section 1 of chapter 1, let's take a look at a couple of interesting cases, some special cases as it were. What I have here is negative 8x plus 5 is equal to 14 minus 8x. And if I go through my equation solving procedures, I don't have any fractions or decimals, I don't have any parentheses, I don't have like terms on either side of the equation. So now I'm down to part 4 where it says use the addition principle to get all terms on one or the other side. So I'm gonna move my x terms. I'm gonna move my x terms over here if I can, and I'm gonna move my whole number terms over this way if I can. All right. Well, how does that play out? I'm going to add 8x to both sides so that I can get the x's over here. And then what I'm going to do is subtract 5 from both sides so that I can get my whole numbers, my integers together. Well, negative 8x plus 8x, well that's 0. Those cancel, and they cancel here. Plus 5 minus 5, well, that's 0 also. So far what I've got is 0 is equal to 14 minus 5, 9. 0 equal to 9. Well, that's false. And so when we have something that comes up like this, where we have an absurd statement where 0 is equal to some other number that isn't 0, basically any false mathematical statement, it is said here that we have no solution. So be careful whenever you are doing your equations. If you're solving for x and you get something strange, then you have no solution. On the other hand, if I use the same procedures over here, I'll add 3x to both sides, and this equation says negative 3x plus 4 is equal to 4 minus 3x. So I'll add 3x to both sides there, and I will subtract 4 from both sides there. Well, what happens when I do that? These, again, they cancel. They go away. Those cancel, so I'm left with 0 on that side. And on this side, these cancel, and these also cancel. So here, I have a statement where 0 equals 0, and it might not always show up as that simple 0 equals 0. It might be 9 equals 9 or 10 equals 10. But this statement is always true. In logic, we call that a tautology. L-O-G-Y, tautology. And in logic, a tautology is a statement that's true just by the way that it's stated. So up here, this statement is true just by the way it's stated. Negative 3x plus 4 is in fact equal to 4x minus 3. That's just using the commutative property. So if we end up with a tautology, then does it even matter what value I substitute in for x? It doesn't. All real numbers will be a solution to this equation. So up here, where we have something silly, some absurd statement, we have no solution. Down here, when we end up with a tautology, all real numbers.